And here in the initial in the current in this current conservation parameters, here we define the electrolyte conductivity, and then here we give this is entirely electrolyte domain. This is where electrolyte will flow. Okay, here the electrolyte will enter, and here the electrolyte will leave. So here this is the anode. So here we apply the potential, which is voltage, and then cathode ground connection is given to the cathode. So here we have 0 volts. So here we apply certain voltage, and here we don't. Here it will be 0. Okay, that is ground. So, and then using deformed geometry, we'll specify the mesh velocity, and here we use Faraday's law. Here we specify Faraday's law. Here this equation which we have discussed in the last class on how we get this, right? It's Faraday's law. We define how this material is getting dissolved. So in electrochemical machining, we'll also give certain motion to the tool, right? The tool also sometimes moves downwards with certain velocity. Say suppose you are doing electrochemical drilling, where you need to make a hole on this sheet. In that case, you have to move this tool with certain velocity, isn't it? So to specify tool velocity or tool feed in the simulation, so what you do is, just in deformed geometry, you will again add another boundary condition, which is prescribed mesh velocity. So if you right click this, here you will find prescribed mesh velocity. So with this prescribed mesh velocity, you can define x and y position of a particular boundary. So in this case, this entire boundary is my tool. This entire boundary is my tool. So I want to move my tool downwards with certain velocity. So suppose you like to do electrochemical drilling. In that case, we are supposed to specify this tool velocity. Is that clear? So to specify tool velocity, we use under deformed geometry, we will add a boundary condition called prescribed mesh velocity, and there we select the boundaries. We select the boundaries to specify the region that is going to move, or to specify the tool field. So say suppose this is simple electrochemical machining. So far we have seen just a simple basic ECM. Here we are applying DC power or DC voltage, where the current, it is just a straight, say suppose 8 volts current, a constant 8 volts current is always applied. Usually, say suppose for the precise applications where we need precision matters, say suppose while drilling micro holes, or for doing any kind of electrochemical micro machining, which we call it as ECMM. So for doing electrochemical micro machining, we have to give pulsed voltage or pulsed DC power supply. Okay, so we have to give this one. So what is a pulsed voltage is, instead of giving a straight constant 8 volts of DC power supply, it will have a certain on state for certain duration, in which it will go 8 volts, and again it will have off state, in which it will have 0 volts. Again it will have an on state and an off state. On state, off state, on state, off state. So this way, this is called pulsed power supply. Okay, this is direct current, this is direct power supply, and this is pulsed power supply. So if you see, these pulses are having rectangular shape. These pulses are having rectangular shape. So these power supply So this pulse power supply is called rectangular pulse power supply. So this is called rectangular pulse power supply. So in this pulse we have certain parameters, which is time period, amplitude, and all. Time period is where from here to here. The duration of this is called time period, which means after this much time, the pulse will start to repeat. You see, over this time, the pulse is always repeating, right? So we have time period, we have amplitude. Amplitude is the magnitude of this one, height of the pulse, and so on. So we want, so in a simulation, if you like to specify this pulse power supply, it is also very simple. All we have to do is we have to, wherever we are giving this potential boundary condition, here we have to introduce a pulse. Here we have to multiply this voltage with certain function, which gives it, which makes it go. So we have to just multiply this voltage just with this function. If you multiply with this, then the voltage will vary just according to this function. Is it not? So how do we define this function in COMSOL? So now let us see that. So, so to define that, so to define functions in the COMSOL, under definitions tab, if you right click here, you will have the options such as rectangle, analytic, triangle. Just a minute. So if you right click definition, here you can see under functions. Here you have different types of functions. You see interpolation, piecewise, Gaussian, rectangle, step, triangle, waveform, random, and so on. So here we let us see just rectangle. Okay. This model is handling about. Okay. So here if you see, this is how you define rectangle. You have to just right click definitions, and under that pop-up you have to find functions, and in function you select rectangle. Just give a minute. Yeah. So here if you see, here we have to specify lower limit, which is the starting point of this pulse, and upper limit, which is ending point of the pulse on x-axis. So lower limit and upper limit are x coordinates which specify starting point of the pulse of the x coordinate and ending point of a pulse on the y coordinate, on the x coordinate. And then you have baseline. Baseline is where your pulse is starting from, and then amplitude. Amplitude is the height of the pulse. Amplitude is the height of the pulse. And sometimes, say suppose if your model is not running, because of this sharp corner, sometimes the model may find it difficult to run at the sharp corners. Like when it is coming across certain abrupt change, if you see the value suddenly goes from here, jumps from here to here. So in those cases, while computation is running, it may face some error. So to avoid that, we have this function called smoothing. In this, you can give either first derivative or second derivative, and depending upon the value that you give, it will just smoothen these corners. You see, by changing this value, it will change the degree of smoothness. Okay. So once you specify your pulse, now this pulse has to repeat. Here we are just specifying this pulse. Okay, here it is going to start, it is going to go like this, and here it is going to be flat, and again it will come down. So this is just one pulse. Now this pulse has to repeat throughout your simulation, right? So this pulse has to repeat throughout your simulation. So now what you are going to do, then go to, we have to, under definitions, we have functions and analytic. So select analytic. So you, when you select analytic, this is what it's going to come. Okay, here. So in this case, here it is showing the triangle one. Okay. Yes. Okay. Here. So here, if you see, this is analytic, and here we will enter the function name, the name of the rectangle function, which is rect1. So in the expression, we will give it as rect1. Okay. We'll specify the function name and then arguments. This function is going to vary with respect to time. So the time we are going to specify. Now here we are going to specify from 0 to, so from this point, so we want this function to repeat this region, we want to repeat, right? This entire region we want to repeat. So we specify the lower limit of this repeating to make it periodic as 0, and upper limit of it is 2. Okay. And here, say suppose if I just, this is just the plot parameters. Here whatever value you give, till that point the function will be plotted. Say suppose here if I am giving it as 2. Just a minute, it is loading. So here when you specify it as 2, it will just plot till 2 seconds. If you specify it as 10, it will plot till 10 seconds. So main point here is For making it periodic, here once you define the lower limit 0 and upper limit as 2, now from 0 to 2 it will continue to repeat. Whatever we have from 0 to 2, that part will continue to repeat. So now say suppose I want this to come as a straight line. Say suppose I want this to come as a straight line with a magnitude of 10. So then what should be the periodic values that I have to set? Can anyone say that? Say suppose I want a constant line. I want a constant line. So here if you see, I change it from -1 to 2. So from -1 to 2, it is going to plot. Clear? If I change it to 4, it will plot in 4 seconds. And from every 0 to 2 seconds, for every 2 seconds, this whole thing will repeat. If I plot till 4, should see 2 peaks. So you can see 2 peaks. This is one peak, this is one, and this is another. So now, say suppose I want a straight line. I want a straight line, the magnitude of 10. Then can anyone say what should be the lower limit and upper limit here? I want to have a constant 10 volts of straight line. Then instead of giving it as a pulse, I want to give it as a straight line. Then what should be the value of lower limit and upper limit? Can anyone write in the chat box? So you have written it as -1 to 10. So say suppose here if I write it as -1 and here if I write it as 10. This is not a straight line. So here, can you understand what has happened here? When we have typed here from -1 to 10. So what it is going to do is, you see our rectangle. Rectangle function, it is starting from 0, is going, and after 1. So this state we call it as on state. This is on state, and this is off state. From 0 to 1 it is on, and after 1 it is off. After 1 it is completely off. So in analytic, when you specify lower to make this period, you are saying that from -1 to 10 seconds, you make this function repeat. So you are saying it that whatever you have, let me type. So here, under rectangular function, we have defined this rectangle. So this point is -1, this is 0, this is 1, this is 2. So this is what we have defined under rectangle. And here this is 10 and this is 0 on y-axis. This is 10 and 0 and this is 1, -1 to 2 on x-axis. Okay. So this is what we have defined in rectangle. Now, in under analytic, if you are going to specify lower limit as 0 and upper limit as say 10, then what it is going to do is whatever you have in this function from 0 to till 10 seconds, 0 to till 2 it is here. So till 10 seconds also here we have, as we have not defined, it will continue it till 10 seconds, 3, 4 and so on till 10 seconds. So till 10 seconds whatever it have, it will consider it as one period. And again it is going to repeat from here again. Again it will start from 0, it will go to 1, again it will go off, and again till 10 seconds it will go like this. 10, 11, 12, 13 and so on till 20. So till 20 it will go like this. So that is what it has happened here. So if you see 0 to 10, again it will go off till here. Now and again it will start. Again it will go off. So this is what has happened. So what I'm asking is, instead of like this, I want a constant 10, a straight line to come. Then what should be the values of my lower limit and upper limit? So to get this straight 10, only this part has to repeat, right? Only this, if this part is continuously repeating, that is when you'll get a straight line. So then what should be the limits of my lower limit and upper limit values? Now can you answer it in chat box? Yeah, it is 0 to 1. So if you specify it as 0 to 1, in this rectangle between 0 to 1 you have a straight line, isn't it? Between 0 to 1 you have a straight line. If you specify that in lower limit and upper limit, then continuously it will repeat only that part. You see here, I will type it as 0 to 1. Okay. And flip flop. Now you see a constant line is coming. It is only repeating 0 to 1. Now say instead of this, we all know sine plot, right? How the sine plot looks. With the argument as x. So, 0 to 6. So now if I plot this, I'm going to get a sine graph. You see here, let me type it. So this is the sign I have defined here. So for the function sine of 2 pi x, for 0 to 1 you will get one complete cycle, and again from 1 to 2 you will get another complete cycle, right? So now or I can just give it as 0 to 1. Even whether I give 0 to 1 or 0 to 2, it doesn't matter, because if I give it 0 to 2, this entire thing is going to repeat. If I give 0 to 1, this is going to repeat. See, it won't change, it won't affect anything. But say suppose I want only upper half. I want only upper half of the sine plot to repeat. Now, can anyone say what should be the limits? Lower limit and upper limit? I want only the upper half to repeat. I want only, so what I'm saying is, in the sine plot, I want only to make it come like this. Only the upper plot should repeat, not the reverse cycle. I don't want this negative value. I want only the upper value. So then, what should be the value of the limits? So what should be the value of limits? I want only this upper plot to repeat.
0 to 0.56.
Yes. If I give it 0 to zero point 0.5, and click plot. Now if you see, only the upper half will repeat. So now, if you multiply this here with electric potential, here it is not. Yeah. So here we'll just specify this function. Here, if you see, this is the analytic one. So whatever we have here, whichever pattern, yes, 6 here, 6 is the volt, or what we can do here is, right, here we just have to multiply this with, just multiply it with an 1. That's it. Here it is. Okay, okay. Let me just open this once more. in the middle because I have defined again sine function. The function arguments has changed. I just open it once again. What is this getting open?